Okay, good afternoon, everybody. Yes, I'll be talking about the methane protocols to evaluating methane reduction in vivo. So you can see the picture there. That's how we measure methane. That's actually taken by one of my students, Liana. All right. So when we talk about greenhouse gas emissions at a global level, we see that most of it is from the energy sector and transportation sectors, and the agriculture sector is about sort of 20%. And if you look at the whole food system, it's probably be 25-30% of the total emissions. And then if you break down the agricultural emissions, then we'll see about livestock and manure, about almost 6%, and then agricultural soils and rice and so on and so forth. And if you look at this, what are the solutions to get us to net zero? A lot of the solutions involve livestock. In this case, the sort of the light blue solutions are all to do with livestock production. Things like optimizing animal feed, expanding the use of anaerobic manure digesters will help us reduce emissions by 260 megatons of CO2 equivalent, or expand use of animal feed additives, about almost 300 megatons of CO2 equivalent. So a lot of these are with livestock production systems. We also have targets. This was mentioned earlier today. We have targets, global targets of reducing methane emissions by 30% by 2030 from the 2020 levels. And when it started off, it was about 100 countries. Now, last time in COP27, it went to 150 countries that have signed up to this. And if all those countries actually did what they signed up to do, then it will save us about 0.2 degrees centigrade warming. So that's quite a lot. We're trying to stay below 1.5. I think there will be a big contribution to that. And in California, also, I already mentioned that we have this reduction of 40% by 2030 as well. So then we need to be able to measure methane emissions accurately, or at least as accurate as possible, in order to quantify what are the reductions that we are expecting. So before we do that, then we need to know where the methane is coming from. So because we are mostly interested in enteric emissions, so I'm just focusing on the ruminant here. This is actually one of the sort of most comprehensive figures that I can find on this topic, which is surprising given the level of interest. And almost everything seems to be coming through the mouth, whether it's produced in the rumen or hand-gut fermentation. It's all pulled out either through lungs or through eructation. And what comes out the back end of the animal is very, very small compared to what's coming out in the front. So this kind of gives us a good idea of measurement techniques. So those measurement techniques that are mostly focused on the front end of the animal will capture almost all of it. So once we know this, then we're confident that we don't need to measure from the whole animal. This is a nice summary of all the measurement techniques that are available now. And this is part of the work that we've done. Ermias already talked about the methane document that is going to come out in September. And as part of that work, we had a dedicated chapter on measurement techniques. And the paper is already out. So we published this paper a few months ago. So the paper is out. You can have a look at that. But basically, what we looked at is there's animal-based techniques, and there's facility-based techniques, and also large-scale techniques. Again, because we are interested more in the enteric side, I'm only going to be focusing on the direct gas measurement techniques and the tracer techniques. So I'm not going to talk about any other of the measurement techniques, because we're going to be here forever if I start to do that. So looking at the direct gas measurements, respiration chambers have been used for some time. I think the earliest recorded use of respiration chambers about 120 years ago. It's been thought of as the gold standard in terms of accuracy of methane. If you do a methane recovery in respiration chambers, you're going to get 99.9% recovery. So it's pretty accurate. And it uses indirect calorimetry methodology, and it relies on gas exchanges of carbon dioxide, methane, and oxygen. And there are two ways of doing this. The most common one is the open circuit chambers that will analyze the composition of the inflow air into the system and then the outflow, and then by difference, how much of methane is there. You could also have a closed circuit chamber that analyzes the composition of the gas that have been accumulated in that closed system. But most of the systems that we use for methane measurement are open circuit. A bit of history here. You're at UC Davis, so in the 1930s, Max Kleiber, who was a professor at UC Davis in the Department of Animal Science, he wrote this book, The Fire of Life, and for that he built a calorimetry chamber. But the respiration chamber or calorimetry chamber at the time was mostly done for energetics, because methane has energy. They are interested in energy. And if you walk into the campus, you will see there's a Kleiber Hall. I think there's a Kleiber Street or something like that also on the campus. And for those animal nutritionists, you will recognize that the two things that he did that we still use, one is the metabolic body weight, metabolic body weight of 0.75 or 3/4 of the body weight has been used since the 1930s. And since the advent of computers, we had a lot of opportunity to try to see this, and we actually tried to see if we can optimize it. 0.75 seems to be too, I don't know, easy, it's like almost a full number. So we tried to see if it is 0.72 or 0.76 or whatever, but 0.75 seems to be the best one. So most people now still use 0.75, except the monogastric people. Then they use 0.66, but otherwise 0.75 seems to work quite well. And that was done through these calorimetry chambers. Another interesting thing, this is a calorimetry chamber or respiration chamber also at Davis. I was able to take the picture before it went away. And this was done by Bill Garrett and Lofgren. So again, people who know their animal nutrition will recognize his contribution, developing a system for expressing net energy requirements and feed values for growing and finishing beef cattle. And this is the system that we still use as well. So with some refinements, we still use this. And also he wrote a seminal book, Animal Agriculture, with another UC Davis professor, Harold Cole. And if you go to UC Davis, you will see the coal facilities there as well. So a lot of history, a lot of the early respiratory chambers were built here at UC Davis, and mostly they were done for energetics, but obviously now we use them for a different purpose. So the modern chambers look a little bit like this, where it's open, animals can see each other, and you can put it into a dairy barn. This one was used, this one I took it in Denmark, at the Follum research station. So you can put a cow or you can put a person in there, and you can measure their methane emissions as well. So they're pretty straightforward kind of to use and easier to for the animals as well, because then you're not completely closed up. And there are sort of different modifications of this. This is in Brazil, where they're using it for goats. So here, Professor Adibi here is gonna uses this to measure the gas exchange for goats, giving them different type of feed, and primarily also used for measurement of methane. So these are calorimetry chambers in New Zealand. This is what they used for sheep to come up with or to identify sheep that are inherently low methane emitting ones, so that through a few generations they can come up with a breed that have inherently lower methane emissions compared to the normal flock. And this is still continuing to happen. But they have a really nice setup. But once they identify this, then they take it out, and then they do it through a different type of measurement. This is again in Brazil. This is probably one of the best setup I've ever seen at the Embrapa station for dairy cattle in Minas Gerais in Brazil. And it's, again, the way it works is to have all this equipment that measuring methane, oxygen, carbon dioxide, and all that. And it measures the whole thing within that respiration chamber. A modified form of respiration chamber is the ventilated hood chamber. The one on top with 2 cows, that is from University of Guelph at the Elora Dairy Station. And basically trying to have 2 animals next to each other so that they don't freak out. And the other one is here at Davis. I think Frank's lab built this hood chamber. I don't know if you're still using them or not, probably still using them. I think that you have 2 now, right? So 2 ventilated hood chambers that are used to measure emissions as well. Again, because most of the methane is coming from the mouth, you'll be able to get almost all of the methane emissions there. And it's a little bit better in terms of for the animal activity, and they can see each other. This is done right in the barn as well. This is the kind of data that you get from a ventilated hood chamber. You have, depending on the setup, you can get it on every minute or every 5 minutes, or if you have 2 or 3 of those, then the sensor will go around those different units, and then it will measure every so often. And then you see that when you're opening and closing, you see that it goes down quite low. And so it's pretty easy to take those out when you're analyzing them. And then on the top panel, you'll see that was a summary of what happened over the 24-hour period. So we are looking at 3 different diets in this case. And then you can see that there is valleys and the peaks and valleys in methane emissions. This corresponds to the time that they were fed. So there's the morning feeding, and then after an hour and a half, it goes up, and then you go down, and then another feeding event, then the methane emissions goes up as well. So this is quite important to understand, because any type of measurement device that we use needs to capture this diurnal variability of methane emissions. For a group of animals, you can use things like a polytunnel. So in this case, a group of sheep that you can measure the emissions. This will be a combination of both the enteric emissions and manure emissions. Also at UC Davis, Frank has this nice setup with then you can measure everything from the animals as well. So you see that there's a ventilation place there where you measure the air that's coming in and the air that's coming out, and then by difference, how much methane is being produced within that confined place. So if you have, I think it's got about 8 of those, then you can use them as replicates as well. But there are some disadvantages of using respiration chambers. One of the obvious ones is the small space. So there's a limited mobility for animals, so they have to stand there for quite a bit of time. So animal behavior is compromised. What we've seen is that the feed intake usually goes down. So we see between 10 to 12% reduction in feed intake. So when you measure the feed intake before you put them into the respiration chamber, and then while they are inside the respiration chamber, about 10 to 12% reduction in feed intake is what usually we see. And obviously, you can use this for animals that are on pasture. Another issue is it's quite expensive to build, although now the prices have come down a bit compared to 10 or to 20 years ago, but still it's quite expensive to build and maintain. But I mean, for accuracy, there's no other better than this one. All right, so moving on from the respiratory chambers into spot sampling. The face masks have been used. They're not used all that much right now because it's difficult to keep the mask on the whole time. I mean, they have to eat and drink and all that. So animal behavior is compromised, but in areas where there's not enough resources, I've seen it been used in low-income countries where they will put it on for like 10 minutes or so, take it out, and then after an hour or 2 hours, they put it back on again and do that. So for that kind of thing, it's okay, but I don't think it's widely used now. The one thing that we use quite a bit is the GreenFeed. Again, this is a spot sampling from CLOC, and the way it works is that you entice the animal to come to the GreenFeed to get those pellets in there. And as soon as the animal comes in, it will drop it pellets, and then as the animal is consuming the pellets, it will breathe into it, and the breath will be then sampled and then analyzed right away. And then all the data is sent wirelessly to the manufacturer. And then you get back kind of cleaned up data, because sometimes the animals don't stay there for long enough time. Usually the minimum is that they have to stay there for about 3 minutes or so. If it is less than 3 minutes, there will be too much interference from outside air. So during the cleanup of data, then they will discard all of the visits that are less than 3 minutes. And then in the end, you get a composite of emission events that you can pull together to then calculate what will be for a 24-hour period. We have a different one now. So the previous one is just there's one bin that drops. Now we have the dual hoppers that have 2 different bins. So that allows for the ability to have 2 different things that will drop into the GreenFeed. So this is important, because if you wanted to have a treatment delivered through the system, then you need to separate the treatment from the control. And so this is the setup that we have in Montana right now. We are conducting an experiment, a grazing experiment, with treatment and control. So this will allow us. And this is from my student that's just finished in Modesto, where in dairy cattle, so you have 2 bins here, and then you put in the different treatments into here, and so that's, you have a control. So in this case, what happened is that when the cow comes in, if it's a treatment cow, it will get its treatment from, let's say, bin 1, and then if it comes back again, second, third time, it will take it from the other one. So it just depends how much of the additive you wanted to include within 1 drop. So we know how much roughly is one drop. If you need them to eat more, then they have to come back again 2-3 times. But the best way is to get it all in once, and then every other time they come in, they get it from the other. So we can program the GreenFeed so that it will deliver just once from the treatment, and then it will deliver from the others every time they come in. And usually you're able also to make sure that they can only visit once every 3 hours, 4 hours, whatever the protocol might be. So this is how it looks like when it's in operation. And the good thing is most cows, I think about 90% of the cows will be okay coming in, and beef cattle as well will be okay. But you will have the 10% cows who would not want to do that. So when you're selecting cows, I think you always have to have 10-15% extra to make sure that that there are cows that won't like it and won't do it voluntarily. Just to understand in terms of how much sampling that you need, so this is a sampling over 24 hours. And so every time you take a sample, you can see that there's quite a big difference. At some point, you can get up to 800 grams per day, and then you go down to 400. So there's quite a big variation within the day. And because of that, you really have to have certain protocol and how many times you need to take samples within a day. So once, obviously, is not going to be enough, because the once could be when it's at the bottom, or it could be at the peak, so you don't know where that might be. So in general, it's recommended about eight times during a 24-hour feeding cycle. So what we do and what other people do is to stagger it in 3 days. So in 3 days, over the 72 hours, the cows, each cow will visit the GreenFeed 8 times. So that way you pull all this data together and you have a sort of a good idea. The manufacturers say 6 is okay, but I think probably the more the better. And for group housed animals, about 2.5 visits per day for about 7 days is what's recommended as well. So if you can't do that for animals to get them this amount of time within that 72 hour, you can also take measurements over a longer period of time, so over a week or so. Then as long as they're visiting it around two to three times a day, then that would be okay as well. And over a 2 weeks period, about 20 visits will be an acceptable, you get a good idea. If you want to have this repeatability in GreenFeed, about 17 days, you get about 70% repeatability rate. And then if you go to 40 days, you get 90% repeatability. So basically, the longer you have, the more samples you have, the better it is in terms of the methane estimates. The advantages of using GreenFeed is really that it's becoming the gold standard as well. There has been a lot of comparison that was made with respiration chambers, and you can see that there was very high correlation between GreenFeed and respiration chambers. And so we have relatively good accuracy, and that's why now there's almost everywhere you go, you see GreenFeed. It has really becoming the gold standard now. And it's pretty easy to use. I mean, I hesitate to say easy to use, but in some circumstances it could be challenging. We have a GreenFeed in Ethiopia right now, and over 2-3 years we are not able to get it done, mainly because of issues with internet and the internet going off and down in the country, and sending gas cylinders over to the country was a bit of a challenge as well. But on the same token, we have another one in Burkina Faso. And this is actually a picture from Burkina Faso where we use goats and sheep, and it works perfectly. No issue there. Every time we need spare parts, last week one of the filters went out, and then within a week they have it and then up and running again. So it could be relatively easy to use. So the other spots of method is the Sniffer method, where the methane concentration from the animal breath is measured. Usually you have the bin at milking parlor and things like that. But unfortunately, there is not a very good correlation with flax measurement methods. There is quite big variability within the animal and between animals as well. So if you wanted to evaluate feed additives, this is not recommended. But for selecting animals, sort of high emitting, low emitting, this might be useful. There's a paper that's in press right now that shows that for ranking animals it may be okay, but if you wanted to evaluate feed additives, this method is not going to help very much. You can see why here. If you look at on the x-axis is the methane from GreenFeed, and the y-axis is from Sniffer. There was almost no relationship. The R-square is 0.0 something, so there was really not much relationship. And we've also tried to develop some equations, and we looked at the data from Sniffer and trying to correlate it with dry matter intake. Again, there was no correlation. And so if there is any strong correlation, there would be dry matter intake with methane emissions. Usually about 70% of the variability you can explain by dry matter intake. So if you can't do that, then it's going to be a problem. But again, you can use it to rank animals in this case. The last one on the direct methodology is the laser methane detector. This also measures methane concentration in the breath of individual animals. And the way it does is with infrared absorption spectrometry. And the person basically holds this device at a certain distance and points it to the mouth and nostrils of the animal and try to get the measurement. And so there's a lot of issues with this methodology as well. I mean, you can get some ideas. Again, for feed additive evaluation, it's not a good idea to use this, but for ranking animals, it should be okay, because you have a lot of frequency, you have a lot of animals that you can do this, and because of those number of animals, then for ranking animals, it seems to be okay. So the last one I want to cover is the tracer method, which is the SF6 tracer method, where you put the canisters on the back of the animals with a known quantity of the tracer SF6, and by measuring how much SF6 has been released, and you can calculate how much methane has been released as well. It's quite difficult to do. I mean, you have to be very precise. You have to measure the amount of SF6 there, and they have to empty the canisters every 24 hours. So there's a lot of work that's involved in this, and also the variability is very, very high. So within animal and between animal variability using SF6 is quite high, which means that you need more animals in order to make comparisons. And the difference with chamber has been shown to be over 10%. So there's quite a big difference between respiratory chamber measured methane emissions and with the tracer method. So this kind of summarizes the main ones. So in terms of the cost of using of those methods, respiration chambers rank highly because they're quite expensive, and sniffers and the laser methane detectors are much cheaper. But in terms of accuracy, there's a compromise between cost and accuracy. The running cost of those things, respiration chamber, again, the high running cost. SF6 is also high running cost. The sniffers and the LMDs are on the cheaper side. And GreenFeed is also, once you buy the device, which will set you back between 80,000 to 100,000, depending what kind. Then there is the annual fees, about $6,500 to about $7,000 a year, which I think is a little excessive, but that's why it costs. When you have one manufacturer, there's not much you can do about it. Labor cost is high for respiration chamber and SF6. For the others, it's quite reasonable. The way we do it here, we usually have one graduate student or a postdoc, and then we have a few undergraduate students, and that seems to work quite well. Repeatability, respiration chamber is on the high side, and then the sniffer and detectors are on the lower side. In terms of alteration of behavior for animals, we've seen respiration chamber is quite limited, while the others seem to be, there's quite low impact on the behavior of the animals. And in terms of how many animals you can go through in a relatively short period of time, respiration chambers, not as much, while the others you can go through a number of animals. All right, so in conclusion then, at the moment when we do, especially in feed additive type of work, the most reliable methods are respiration chambers, GreenFeed, and SF6. But I see that a lot of places now, the GreenFeed seems to be the method of choice. For now, these methods are actually adequate to measure methane. I think we're getting good estimates of methane. And it should be good enough for any kind of verification for purposes of carbon credits. So I just want to say thank you to all the graduate students and postdocs who have done this work, and a lot of the support that we're getting to do all this work as well. Thank you.